Hi. So we're going to use hole-driven development to help us work out the definitions for pure and the star thing for the applicative instance of compose FG. So compose lets us make use of a wrapped value. So if you have a list of maybes like this, just 2 and nothing, that's of type list of maybe, and we can store that in our data constructor make compose. So that turns it into a compose, and then F over here, the F corresponds to the list, G is maybe, and X is the internal type, which here is just a number. So the goal is to write the definitions for pure and the star thing. So just to recall, pure takes a value and wraps it into some context, and the star thing takes a function that's inside a context and turns it into a function from a wrapped value to a wrapped value, or a value inside a context if you want to think of it that way. So an example, if you were to turn pure into list of ints, that would put it inside a list. If you instead asked for that as a maybe event, that would put it in a just 3. So it just is the simplest way that you can sort of embed the value in that data type. And the star lets us take, for example, if we have a value, so a maybe of a function, we can operate on a maybe value using the star. So it kind of takes the function out in some way and applies it to that value over there on the right hand side. So in hole-driven development we have 2 holes. There's a sort of a noisy hole with a capital H, and that's just defined using a simple data type that has a single constructor, doesn't take any parameters, and we can use that to provoke a type error where GHC will tell us we expected something and we actually got something else. And we'll see that in action later. And the sort of quieter hole with a lowercase h is just a synonym for undefined. So that lets us write partial definitions without having to fill in all the details. So the first thing we'll do is just change that to a noisy hole, and I'm using GHC mod vim, so as soon as I save I'll get an error message here, and it tells us that it couldn't match the expected type compose FGA with the actual type of hole. So the only way we can create something of type compose FGA is to use our data constructor, so we'll just put that in. That type checks so far, and now we'll ask give me another sort of type error here. And now it says that it was expecting something of type F of GA, but it actually got a hole. So given that we are operating on things that are applicative, so F and G are in applicative, it means that we have access to their pure functions. So we do have a way to call pure to create a value in that context. So we can do that, and that still type checks. And if we go one step in here and ask what this error is, it'll say that it couldn't match the expected type GA with the actual type hole. And so again we can use pure because it's there for us. If we save that, and that's okay, so now we push a type error, and it will say couldn't deduce that A was the same type as whole, and we know that X is of type A, so we can just pop an X in there, and that turns out to be okay. So we might be able to do an example of that. If we asked for pure of 3, and it was a compose list of maybe events, it pops it in like that. So it's basically using the existing behavior that you'd expect from the list and maybe being instances of applicative. So now we'll just turn to the star thing, and the first thing to note is that Fn here, if I ask for the type, it's a compose Fg of A to B. And the problem is we can't do much with that because it's the actual value that of types f and g are sort of inside, so we have to use pattern matching to just kind of pop that out by one level. And we'll do the same on to the x, because that just gives us a bit more to work with. So now if I ask for that type, it's an f, g, and then a to b. So there's a function that's wrapped up twice, and the x is a value f that's wrapped up twice. So, given that f is an instance of applicative, it means that we have access to its star operator. So it's possible to write something there, that star thing, and then the x. Oops. And it's telling us that I got something wrong at the beginning. I should be doing a make compose of something. So now that we have that kind of structure there, we can ask the type system what the format should be for the thing that's going in here. And not too surprisingly, because x is of type f of blah, it's expecting this side to be f of blah. So in particular, it's a wrapped value, so using f we've put some value inside the context, and you'll recall that the pure function is something that takes whatever and puts it inside a context. So the only thing that really makes sense at that point is to use pure, and that does type check. If we ask it again, or poke it a bit and get another type error, it'll now tell us that it was expecting something of type GA to GB, so a function on these wrapped values. So how would we get something of that type? There isn't really much around. If we look at, so if we just remind ourselves, fn has that data type. I might just grab that. So I'll just change this to be a sort of a function. Just we'll pretend that we have the right answer there. So just say that we have a function called convert that takes that. Give that a just make that a whole, and its type is going to be that thing that I just selected, and it's going to an FGA to GB. I believe that that was correct, yep. So I got ahead of myself a little bit there by sort of seeing that we're going to use the pure function, but it started to get a bit hard to reason about it in that particular spot. So I just stepped back and said, let's pretend that we have the answer and call it a function convert that takes our functions and manipulates them in some way so that they'll operate in the right way on this x value. And so it's taking these sort of doubly wrapped functions and turning it into functions that are wrapped just one level, so f, and then they're different inside that they're GAs to GBs. So we don't know how this will do it, but it's given us, it sort of gives us a bit of a different context in that it's saying that all we have here are just the functions and we have to do something to them. So at this point we know that h would be would have an applicative stuff defined for it. So again we could pretend, or we could write, you know, some operation on h in a uniform way that's going to change how these functions behave. That type checks, and it seems okay, so we can push it a bit more here and say what's going on with that. And here it's saying that it thought that we'd have an f g a1 to b1 to g a1 to g b1, and that looks suspiciously like the sort of the star function, except that we've got this f around the entire thing. So it is f and then a bracket, and it goes all the way over there. So just like when we're doing the pure thing, we know that we have to use pure to create this value inside the context. So it's going to be pure of something, and then we can push an error on that, and it will tell us now that the thing in here has to be something that takes a function that's wrapped up in a single context G into a GA1 to a GB1. And that is, if we go back, maybe I don't have it, yes we do, that pretty much matches the type for the star that we had. So we can just see what happens and just drop that in, see if the type system can work this out. Oop. And save it, and that all type checks. And this turns out to be the right answer. It's not a proof that it is the right answer, but it's probably a good shot at the right answer, because we still have to verify the applicative laws independently of what we're doing here. We can give this a little test run. So first we'd have to make a type using make compose, and then we'll put a function inside a maybe, so we'll have a +1 and a nothing. We'll just store that in fn. So that worked. If we just check that, it's a compose of list of maybe, and then inside there's the integer to integer function. And for some values, we use make compose again, and we can just have 100, 200, and nothing. And if we just double check what that value is, it's compose list of maybe of integers. And now if we do fn star on x, we get pretty much what we expected, because we're just using the existing instances of applicative here. So the first function is, you recall, just adding 1, so it gets 101, 201 and a nothing, which corresponds to those three values. The second function is a nothing function, and it kind of makes sense that a nothing function would just produce a nothing value, and indeed that's what you get here, that there's nothing, a nothing and a nothing corresponding to the three values in the x. So this is the definition for star, and we could tidy this up a little bit, because we can reason kind of equationally with Haskell if we just comment those out. Oops. Yep. And instead of the convert, we can put its sort of actual definition in, so that would be pure of that, and then operating on that, and that checks out. So that's actually the definition